In this lesson, we're going to take a quick look at something called the principle of inclusion and exclusion. Basically, when we look at diagrams, Venn diagrams, we've already seen this before where there's a little bit of a problem when we look at union size versus the individual size of each of the bubbles, which they don't add up properly. And the reason for that is that there's this intersection or overlap that gets double counted. Because of that, when we ever want, or whenever we want to calculate the number of things in a union, what we're going to do is use this equation right here. Once I have my marker ready to go, this equation right here, which says the number of things in a union will equal the number of things in first set plus the number of things in the second set minus the intersection. And if we look at the picture down here, the reason for that is that the intersection right there got double counted. So when we added A and B together, that football shape in the middle basically got counted twice. So in order to correct it, we take the number of things in A, add the number of things in B, and then subtract off the number of things in both. So add the two circles, subtract off the football, if that makes sense, and hopefully it does. So just going to immediately jump into trying some examples of this and seeing what kind of information we can draw from it. Now, again, this is one that I did in class, and it becomes a little bit more difficult when we're trying to do it without student immediate feedback. So I'm going to kind of just walk you through it and draw the data that I got from the first time that I did this with my course. Or I should say the last time, I suppose. So I'm going to have, you know what, why did I make, I was trying to draw it so that I'd have room for a third circle, but this one only has two. So let's do that. And in this particular one, what I did is I polled my class to see how many of my students were female. Again, not a particularly tough question to ask for the most part. And how many of them are in the arts package. We just have a special program at my school for arts students. It's a magnet program. Don't get too worried about what that actually means. It's just basically arts students. So our two bubbles that we're looking at, our two criteria, are female and arts. And when I asked how many students were taking both of, or how many students met both of those criteria, 4 people put up their hands. And when I asked how many people when I counted how many people were female, 17 people put up their hands. And when I counted how many, or asked how many people were arts package, 9 people put up their hands. We've already got those 4 there, so there must be 5 more over here. And again, this was a class of 30, so we're going to put the number, or we can calculate the number that goes on the outside of this. We've already accounted for 22 students, which means there are 8 students out here in this part. So now that was the information that I collected and the information that I graphed in the Venn diagram. The questions now are, can we answer these other problems without actually asking the class? So the question part A is how many students are female or in the arts package? So how many students meet at least one of those criteria? And looking at the diagram, the criteria basically is you have to be inside one or both of those bubbles. So it's going to be anyone except for the 8 on the outside. So whether you add the 13, 4, and 5 or subtract 8 from 30, you'll get the same answer. It's going to be 22. Again, it's whether or not you want to do direct, which is adding the 3, or indirect, which is 30 minus the 8. It's your call. How many are males in the arts package? Now, the question never asked anything about this. Now, I should point out that in this particular class, I did have no students that recognized as anything other than the binary, male and female. Ironically, I usually do. But in this case, male and female were the only 2 options for the class that I actually polled. So now the neat thing is we never collected information about males, but if you're a male in the arts package, it means you're inside the arts bubble, but you're outside the female bubble. So inside art, outside female. And that would be those 5 right there. They're inside the arts bubble, but outside the female. The 4 in the middle is inside the arts bubble, but it's female. So we have 9 art students, 4 female, 5 male. And from that, I can conclude the answer is 5. And by the way, when we did this, I got them to like raise their hands when they were that. I'm like, how many guys are there in the arts package here? And 5 of them put their hands up to verify that our math did work out. Usually it's one off because somebody's sleeping and not paying attention, doesn't put their hand up at the right point. And how many males aren't in the arts package? Well, males not in the arts package mean that they're outside of both bubbles. So that would be those 8 down there. And so I can conclude that there must be 8. So that's actually about it for the principle of inclusion exclusion. It's add up the individual 2 sets, subtract off the number that is in both of the sets because it got double counted. All right, so that's the rule. Now we just have to expand it a little further, which is where it gets interesting. So that's the equation for 3 sets. Now I know what you're thinking. I don't know why. I got to get rid of the crayon on here. I hate using the crayon. That equation looks horrifically nasty. And realistically, it's not as bad as it looks if you actually understand where it comes from. So in my in-class version, students are actually expected to memorize that. I don't give it to them on the test. And they're actually supposed to do the one for 4 as well. But again, it's not a matter of memorization. It's a matter of understanding where the equation comes from. So I'm going to try and draw a picture using different colors on the diagram below, just to show you how that equation is actually pretty simple. And the equation basically says, take all of the things in A plus all of the things in B plus all of the things in C. So that's number of things in A, number of things in B, number of things in C. Now, unfortunately, what that did is it led to a couple of football shapes that got double counted. So what we want to do is subtract off that football, subtract off that football, and subtract off this football. So that's the AB football, that's the AC football, and that's the BC football. Now finally, there's that one little middle section right there, the fat triangle, which got added in 3 times. It got added in because of A, it got added because of B, and it got added because of C. So it was actually triple counted. But then it got subtracted from the first football, subtracted from the second football, and subtracted from the third football. So it got triple removed. So it's not there anymore, which means we have to add it back in. So again, don't try to memorize that equation. I wouldn't even try to like look it up and use it. I would just look at the diagram and logic my way through this. Add the individuals, subtract the doubles, add back in the triples. So for example 2, this was another example of one where I was trying to collect information and we wanted to see how it worked. So I'm going to just share the information with you that I collected. And it was for females. That was one of the criteria with dark hair. And I let students decide whether they considered their hair dark or light. And students who are taking English this semester. The reason I picked these 3 is because it becomes a more interesting diagram if each of the things is approximately half. If one of these things is a null set or very small, it makes for a very boring diagram because you've got a bunch of blank areas in it. But it does a whole bunch of things. So I tried to pick things that roughly broke up the class into halves for each of the 3. So I'm just going to draw this diagram. And I'm going to draw this diagram with the 3 bubbles. So a little bit trickier than the 2 bubble version, but not too bad. And when I did this, I'm just going to jump to the diagram rather than try and talk you through it because I'm going to lose people anyway. Of the 30 students I had, sorry, this was female, dark hair, English was the bottom one, and the answers were 4, 6, 4, 3, 4, 3, 5, and 1. And if we quickly double check, those should add up to 30. We have 10, 15, 25, 29, 30. Yep, that works. Okay. So basically the information I collected was how many people are in F, how many people are in D, how many people are in E, how many people are in F and D, F and E, D and E, and all three. And then from that, we can make conclusions. So for instance, let's just double check, I don't know, one of these, or let's actually make sure that the math on this one works out. So if I want to know the, I'm just going to go back up to what the principle of inclusion exclusion says. If I want to know the number of people in A union B union C, or in this case, F, D, and E, I should say, I'm going to have to do this. Ask myself, how many people are in F? I'm going to actually work these out and write them at the side just so that we can kind of see them. The number of people in F, so we're looking inside the F circle, and I see a total of 17. We're going to look inside the D circle and see a total of 18, I believe. I was going to say, if you see me making a mistake, yell it out. Unfortunately, I can't hear you because it's a video. Hopefully I won't make a mistake, and if I do, we'll try and correct it before the end. Number of things in E is 14. And then I have to collect information about the doubles. So there's 3 doubles, number of things in F and D, F and E, E and F. No, E and D. By the way, I put E and D. It could have been D and E for alphabetical reasons, but it doesn't matter. They're the same thing. And finally, I need the number of things in F and D and E. So F and D is a football that has the 6 and the 4 in it. That's 10. F and E has the football with the 3 and 4, which is 7. E and D is the football with 4 and 3, which is also 7. And all 3 of them together is the fat triangle in the middle, which is 4. Okay, so let's see if this actually works out. Now we know that F union D union E should be 29 because it includes everyone except the one person who didn't meet any of the 3 criteria. It should be 29. Let's see if it works. So again, rather than write out the whole formula, which is very time consuming and long, I'm going to look at the numbers and say, add the singles. Now subtract off the doubles. Now add back in the triple. And if I were lucky, fingers crossed, this should work. 14 plus 18 is 35, plus 14 is 49, minus 10 is 39, minus 7 is 32, minus 7 is 25, plus 4 is 29. And that is exactly the number of people that we thought should be in the union of those 3 things. If the numbers didn't work out, a couple of things could have happened. Usually when I do this in class, the mistake is I won't say that it hasn't been my math, my basic mathematical skills. I do mess up like everyone else. But in general, it's usually because 1 or 2 people are not paying attention and put up their hands sometimes, but not other times when they're supposed to, and it causes weird contradictions. So putting up your hand and saying that you're female and in the arts package, but then not putting up your hand when I ask for just arts package, it messes up the numbers in a way that they can't possibly work out. Incidentally, a contradiction in a table like this usually means data was collected improperly or was incorrect to begin with. Okay, so that's how it works with 3. I'm going to stop there, although I'm going to let you think about how you would do this with 4 overlapping sets, because there is a pattern there. When it was just 2, we added the singles, subtracted the double. When it was 3, we added the singles, subtracted the double, added the triples. For 4, you figure it out. So I'm going to leave you to think about that. And other than that, I think we're going to call this one a relatively short lesson. We'll see you next time.